How many users use laser lithography?
Over the last year, we had about 200 CMI users from about 40 different laboratories using our MLA 150 equipment. Since its installation in 2014, we have trained more than 400 users on the system. So this is one of our most active system, and basically every user has to do some photolithography at some point. We have a second equipment, a VPG 200, which also has similar statistics.
What type of resists do the user use?
They have very different needs, and consequently we offer a very broad range of photoresist. So there are the very thin, below 1 micron photoresist for high resolution applications, some thick resist for high aspect ratio. We also have solutions for liftoff processing. We have positive and negative photoresist. We also work with different type of chemistries such as SU8.
What is the state? I mean, you must be trying to achieve better and better resolution. So what is the state of DPUV in the facilities? Would you see the need for a DPUV laser lithography sometime in the future?
We are lucky to own the DPUV stepper with an inline connection to a coating and development track. So this operates at 248 nanometer. And this is basically the state-of-the-art configuration at this node. So the printing performance is great. Resolution can go down to 150 nanometer with very good uniformity and high throughput. So in our case, we do not see the need for a DPUV laser writer. As you know, DPUV lithography, it has merits in terms of resolution, but it suffers from restrictions and limitations compared to the more mature and I would say the more versatile I-line photoresist and I-line processes. So,
and users that want to go even further can use the e-beam lithography. Do you use also the scanning probe lithography technology?
So we have an e-beam lithography equipment. We are planning to purchase a second one in the coming years. We do not have a nanofraser equipment in the CMI, but we have one installed in one of our partner laboratories, which is EPFL LMES1. They have used the system since 2017. And basically, in our case, we may collaborate on certain projects, and we follow the updates on the technology.
An actual topic with photolithography is also 3D printing of micro and nanostructures. What can you tell us about two-photon lithography at CMI?
We are equipped with one 3D laser writer based on two-photon absorption. They are really exciting equipment because it lets you print basically everything. We have a certain number of groups that are active on this equipment. They work mainly in the fields of micro-optics, micro-robotics, applied photonics, and microfluidics. And yes, the tool is used daily. It's kind of niche project because they are still a little bit slow in terms of printing time, but very exciting types of equipment.
Since the CMI has good collaboration with the industry, could you tell us more about what kind of industry adopted photolithographic process? Do they usually invest in their own equipment, or can they also come and use your facilities to produce?
So they can come and use our facilities. But as you know, our missions are mainly focused on research, development, and training. So we are still based on small wafer sizes, 100 millimeter. And we do not necessarily have the equipment for industrial scaling in terms of large wafer sizes, high throughput. So industrial partners, they come to our facilities to develop projects, but most of the time when they are happy with this, they have their own facilities for scaling.
How do you see the optical lithography evolving in the next 10 to 20 years?
So I think we already discussed a little bit about high resolution processes, so scanners, extreme UV. in terms of budget, this is completely out of reach for CMI. So I expect that the traditional 2D photolithography will remain the main photolithography method, and maybe still here in 20 years, together with E-beam lithography. This i-line photolithography technology is mature. The process are stable. Equipments are mask aligners and laser writers. They are cheap and constantly improving, so they will stay.
What will be your needs then in terms of resolution, throughput, or are you even planning to go from 100 millimeter to 200 millimeter at some time?
It really depends on the needs of our users. So we have a selection of users that needs the high resolution, but we are some which are working, in hundreds of microns in terms of dimensions. So it's good to improve the resolution, to improve the uniformity, to reduce writing times, but maintaining the stability of the process is also very important for us, since we have a very broad range of processes and photoresists.